Exponential functions will be different. So linear functions took what form? Do you remember? What was slope-intercept was this, y equals mx plus b, right? That was a linear function. But we're not talking about that today. We're talking about an exponential function, which is a nonlinear function, meaning its graph will not be a straight line that takes this form. This is standard form of an exponential function. Y equals a b to the x.
What is a, wait, linear, so it won't be straight?
It won't be a straight line. It'll be a curve.
What the heck?
Mm-hmm.
Is this going to become as easy as y equals mx plus b will?
No.
So what does
Okay, couple things to note. A and B, we'll go through each of these, but A is a constant, so it's going to be A and B will both be numbers. Okay, so it'll be a number. A can't equal 0. You don't really need to know that, but like it's just part of the restrictions of an exponential function. A cannot equal 0. It's got to be any constant other than 0. So 1, 2, 3, 7, -2, whatever. Can't be 0. Here's the important part about exponential functions. This is what makes it exponential. The x value is an exponent. Do you see where the x is in this function?
Mm-hmm.
So rather than being sort of as a base, now our x in the function is an exponent. And that's how we identify an exponential function, is that the x is an exponent. Okay? Okay, whatever that a value is, and we'll talk about this more as we start looking at graphs, but whatever that a value is, it tells us the y-intercept of the function. So it tells us where that graph crosses the y-intercept.
Oh, I thought b was the y-intercept.
That's in linear functions.
Oh.
That's in linear functions. In exponential functions, the a
So is there
tells
always
us.
an x value?
Is there a what?
Is there always a x above b?
Yes. X will always, for it to be an exponential function, x will always be in an exponent place, in an exponent position. Okay, and then, yes.
Is this the same section?
It's a new section. It's a new
We
section.
haven't taken like tests on all the exponents or different.
We only took those 2 tests on the rules about exponents. Like we took the quiz. Then the last part of this is that b has to be a constant that doesn't equal 1. What would happen if b equaled 1 and we were
It would cancel it out, because it would just be whatever the y-intercept is times itself.
okay,
Or times.
Oh, because the exponent wouldn't be important at all because it wouldn't do anything.
bingo. When you take 1 to any power, what does it become?
Oh,
1. So if you have a base of 1 and you're taking it to an exponent and you change that x to anything, what's it going to do?
Turn it to 1.
Nothing. It's always going to come back to 1. So we can't have 1 as our base because that won't correctly make an exponential function. Okay, so let's look at some more here. Okay. We can see, so like when we were talking about linear functions, we could look at a table and determine if the relationship was linear. Because remember, they had a common, I'm going to forget the difference, a common difference. You were adding or subtracting the same amount from one to the next. An exponential function will increase or decrease by a common factor. So rather than adding or subtracting the same amount, you are multiplying or dividing from one to the next by the same amount. So rather than adding or subtracting, you're multiplying or dividing. And we call that the common factor, whatever you're going multiplying by to get larger or dividing by to get smaller. Oops, sorry. Sorry. I didn't realize I was going to the next slide. So this is going to force you to recall back the rule for linear functions. We're adding or subtracting. If we're adding or subtracting the same amount, it's linear. If we're multiplying or dividing, it's exponential. So here's our little chart. Let's figure out the relationship between the values. So let's start with x. Remember how we would do this? Okay, x is going up by, okay, a common value. Now, it's the relationship of the y's that matters for linear or exponential. What is happening to our y values? How is that going up or down?
Going up by 2.
Good. It is going up. We are adding 2 to every term in order to move from one to the next. So is this a linear or an exponential relationship?
Exponential. Wait, but I thought you said if it goes up by a common factor.
And what did I say?
It has to be multiplied or divided.
Yes. It has to be multiplied or divided. If it's adding or subtracting, it is linear.
Linear. It's a weird word.
Okay, and we call it a common, for linear functions, it's called a common difference of positive 2. So every time we're going up by plus 2, plus 2, plus 2. So linear. Because we are adding or subtracting. And in this case specifically, we're adding. Okay, look at letter B. Okay, we always check that x is going up consistently, but it's not the relationship of the x's that matters. It's the relationship of the y's. Good. Notice what's happening to our y values. To move from one to the next, we are doing what?
Multiply by 2.
Multiplying by 2. Okay, and because we are multiplying, how would we classify this function? Exponential. And that's because we're multiplying. And notice how big the numbers are getting quickly, right? Because every time we're multiplying by 2. So we say that we would say that there's a common factor of 2. I think it will ask you in the homework, like they'll say explain, and the way you explain is it's a drop down. Common factor of 2.
Exponential graph of 2.
No, because you have to say what of 2.
Common factor.
Common factor of 2. Right. You have to say what is up to. To evaluate exponential functions, this seems easy enough. Plug in a given value and solve for the other value. So they'll give you an exponential function. They'll say evaluate when x equals blank. And then you plug it in and figure out what y equals. Seems easy enough.
That doesn't make any sense.
It will. We'll look at this one. I'll put this up here and let you copy it down, and then we'll do it together in a sec. Okay, so here's what we're doing here. When x equals 3, we're going to figure out what y is, right? So we're given an input, and we're going to figure out the output. Here's the key. So first, we're going to plug in, leave everything else the same, and plug in a 3 for our exponent. Order of operations comes back up. We always have to pay attention to order of operations. The temptation, and don't give into it, the temptation is to do 2 times 5.
No, it's 2 or
It's 2 to the 3rd power to 5 to the 3rd.
No.
it's 5 to the
Just
power
5
of
to
3.
the 3rd.
Okay.
But what about the 2?
What's the exponent of the 2?
1.
Yeah.
Don't you-
So first,
Isn't
we
there an
must
exponent of 1
we
and 5?
must do this first. You must parentheses exponents are first 2 things in order of operations. We must do the exponent first before we do the multiplication.
But doesn't it go parentheses then exponents?
Yeah, but can we simplify within these parentheses?
No.
No. So then we move on to exponents.
Does the 5 also have a 1 over it? Should the 5 have
Technically, yes. And so then we, give the 3 to the 5, but only to the 5. What's 5 to the 3rd?
125.
Okay, so then we do 2 times 125.
250.
So y equals, good, 2 50. Now, if you had gotten 1,000, you would be wrong. It's not 1,000, it's 250 because you must take that base to the power and then multiply by the coefficient in front of it. Okay? Okay, here we go. Here we go. Right off the bat, just to pertain to your question, here's a negative exponent.
Don't we just turn the entire thing underneath like the bar? Like
That's after.
Oops. 0.5.
For everything.
But what if you put that on top? Then you can simplify.
No.
Okay, what goes under the fraction bar?
5 to the negative
0.5
2.
is negative 2 now.
Yes. Does the whole thing go under?
Just 0.5 to negative 2.
No, because 3 has a positive exponent. So this becomes y equals 3 over 0.5 squared. Right? Because then we drop it down. The exponent becomes positive. Now can we simplify this?
Yeah, you can.
3 stays the same. What's 0.5 squared? 0.5 times 0.5. What is that?
1.
0.25.
Wait, how does that work? Oh wait, never mind. That was a dumb question. That was a dumb question. But shouldn't that be like 0.50 times 0.50? So how is it less than?
It's a half times a half. So a half of a half is 25, is 25% or 0.25.
Okay. That makes
Okay.
sense. I was looking at it like it's
You
0.50
have to
times
take-
0.50. So then it should be like.
half of that halfway. There's still this.
Yeah, that's
Okay,
Okay, that was actually helpful.
the last step in evaluating, we cannot leave a decimal in a fraction, so you would have to do the math here. 3 divided by 0.25 would be what?
Quarter 12.
12. Very good. Okay, how many quarters are there in 1?
1, 4.
4. And how many ones do we have?
3.
3.
times
So,
four is
yes.
11.
Okay, if you don't get this mental mathly, what will you be allowed to use? A calculator. But do not leave.
Oh, I made it. Oh, I got it.
Oh, it's a negative gravity. Oh, damn.
Oops. Yeah, 2 times 9 to the negative second. What is going to drop, Malia?
1 to the second.
Yeah. Only this part's going to drop below our fraction bar.
And you can't simplify, can you?
2 over 9 squared.
You can't simplify 81. You can't split it.
We can't do any more exponent rules, but we can't leave it like this. This becomes 2 over what? 81. You can leave it like this.
Yay.
All right, here we go.
Max, I need you to move. How about just like this?
2 times 9. Okay, and we're plugging in 1/2 for x. What do we do here?
Okay, so.
Well, good thing we didn't just start our homework because we don't remember how to do this.
Wouldn't it be half? Wouldn't you be multiplying by technically half? So that.
No. What does a rational exponent do? What does this become?
That's a 2.
Yes, exactly.
got it.
Where the 2 goes. Is
Yes.
the squares has
Yes.
Wait, what?
No, it's what we. The denominator goes into the box.
Yes, it becomes the index of our radical. Right? Right?
Yes.
Yes. So now can we simplify that? What is the square root of 9?
3.
3. And what is 2 times 3?
No, sorry.
2 times, just 2
I
times.
thought that you were another example with that.
6.
When do you have to do that?
This is single round equals. Wait, 1.
1. Just 1.
Yeah. So it's
So
negative.
negative 3.
It's
Negative
negative
2.
3.
Yes.
Huh?
Because we get negative 1/4 to the x, and then we plug in a 0. This whole factor becomes what?
1.
1.
Anything to the 0 power is
Negative
1.
3 plus 1.
No, what is it? Negative 3
Why though?
Because it equals 1, which means that you times it.
times 1.
Okay, so you just leave it at that. You don't have to flip. So you don't have to flip it because there's no exponent.
Correct. There's no negative exponent, so we don't flip anything. The negative 3 is just a coefficient that we're multiplying.
Chop the tree
Wait, can you
down.
go back to the other one?
Exponent in these equations.
Yes.
Can you go back to the other one?
All right. Our negative 2 is going to go right up here. So we get y equals negative 3 times 1/4 to the negative second. Okay. First thing I want to do is I'm going to want to drop this, right? To get that exponent positive. So we get y equals negative 3 over 1/4 to the second.
Actually a lot easier than
Yeah. It's just, you just really have to be systematic and just, because what's the exponent of negative 3?
Which means it's not a negative. So you don't have to drop
The
it.
base won't change.
Okay. Now we can start simplifying. What's 1/4 squared, or 1/4 times 1/4?
Wait, no.
Yeah.
1/8 or something like that.
No, it gets bigger, right? So it's no, it doesn't get bigger.
Look up at the board. How would I do that? 1/4 times 1/4.
Oh, you do the little boxy 1/16. What?
Cannot leave a fraction in a fraction or a decimal in a fraction. So there's a couple things we can do. Remember, a fraction bar means divide. So if you wanted to do it by hand, you could do negative 3. We would do copy, dot, flop, right? Copy, dot, flop. So we get what? Negative 6 times 3 is 18. You can leave it open. 48. Okay, or you could turn this into a decimal first. Well, you'll have, the thing is like with a calculator, it's not a ton of work. And then you do negative 3 divided by whatever that is as a fraction, something tiny. I don't know it off the top of my head. Either way, you end up with a negative 48.
I missed a little bit when I left. Oh, I never
That's the same one. Oh gosh, then that's part 2. We won't even start that.